Hey guys, welcome back. Today we are going to be looking at how we convert our decimal numbers to binary. Right? So we want to look at 4 simple steps and we are going to look at an example and get things going. So let us start with that here. Step 1. It says divide the decimal number by 2 and record the remainder. So that's step 1. Step 2, we are going to divide the quotient by 2 and record the remainder also. In that process, we are going to continue for step 3. Continue the same process until our quotient value now becomes 0. The last step, we are going to take the remainders from bottom to top and write them from left to right. So we have 4 steps. So let us first look at how we are going to convert 18, which is in base 10. Base 10, which represents our decimal system, which represents 10 digits. And we are going to convert that to binary, which is representing 2 digits, zeros and ones. So let us look at how we convert. So we're making a simple table here. So we represent the 18 and we're going to divide the 18 by 2 and then we are going to look at the remainder. Right? So we are going to look at how we deal with the remainder here. So we say 2 can go into 18 and we can go 9 times, leaving no remainder. Let's continue the process. Divide 2 into 9, it goes 4 times. Yes, we will have a remainder. Then we'll continue the process again. 2 can go into 4. It can go 2 times, leaving no remainder. 2 can go into 2, 1 times, remainder 0. Can 2 go into 1? No, it can't. But we still have that remainder here. So we would complete changing these numbers to our binary equivalent here. So the final step now is to write from the bottom up and from left to right. So we're going to write down our answer now here. It would have been 1, 0, 0, 1, 0 in base 2. And that is our answer. In converting 18, which is in base 10, to binary. And that's how we convert a simple decimal number to binary. So we will look next at how we convert our binary number back to decimal. So stay with us. Alright, so let's continue where we left off. Now we're going to look at the same conversion. We're going to look back now, changing that binary number to its decimal equivalent. So we have a few steps that we're going to look at converting binary numbers back to decimal equivalent. So look at the steps that we have here. It says step 1, write out the binary number. So we have our binary number that we're working with, which is 10010. The equivalent that we had for 18. So the next step, it says for each digit write out the place value in base 10. So we're going to look at the place value equivalent for that. After that, we're going to do multiply each digit by the base 10 place value. So we're going to multiply each binary digit by the place value that we have there. And the last step is for us to add the results. So we're going to look at this now. So remember that we had our binary value, which was 10010 in base 2. We're going to convert it to decimal. So we create a simple table here to illustrate. So at the bottom here, we put in our binary values. So each binary digit has its own place value here. So we have it in terms of 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and 2 to the 4, etc. Increasing in power. We know that any number that raised to the power of 0 has an equivalent of 1. So any number raised to the power of 0 is 1. 2 to the 1 means 2 times 1, which gives us 2. 2 to the 2 means 2 times 2, which means 4. 2 to the 3 means 2 times 2 times 2 give us 8. 2 to the 4 means 2 times 2 times 2 times 2 give us 16. And we continue the process as we go along. So what we are saying here, for these binary powers, it has its own decimal equivalent. So we could say this is our decimal equivalent that we have here. All of these values go in here. So when we insert, and we always start from the right, so the first digit 0 would be under the 2 to the 0 column, the 1 would be under the 2 to the 1, 0, etc. If we had another number here, we would continue the process going that way. So what we are left to do now in the last step is that we're going to multiply each digit here. So the decimal value that we have here must multiply by the binary value that we have here. So we'll start off by saying 16 times 1 give us 16. Plus, as it says here that we need to add the results. Plus 8 times 0 give us back 0. Plus, so we know that any number that we multiply by 0, the result is 0. So we know that this one will result in another 0. 1 times 2 will give us back 2. Plus 0 times 1 here will result back to 0. So we add our results and we are now end up with 18 in base 10. So our decimal equivalent for this binary number will come back out as 18. So that's where we leave it for now. Thanks.